A uniform chain of length L and mass m overhangs a horizontal table with its 2/3 part on the table. The friction coefficient between the table and the chain is mu. Find the work done by the friction during the period the chain slips off the table. So the diagram is the same as the previous problem. So we are considering this diagram itself. So this is the diagram which we have. Now in this part the problem is saying if this length segment slips down, if this length segment slips down, then what is going to be the work done by the frictional force? So the normal reaction force equivalent to this mass is going to be 2 mg by 3. But the problem is as the chain is sliding down, the normal reaction force will change because the weight is changing which is on the table. So for this particular problem, we are considering it in this sense. Let x length of the chain be on the table at a particular instant. We are considering that x length of chain be on table at an instant or at a particular instant. So now in order to move this length, we first of all calculate the mass of this x length or dx length that we select from it. So we say that the L length of the table have a mass m. So the x length of table is going to have a mass equal to m by L into x, or the dx patch which we select will have a mass equal to m by L into dx. So now the work done by friction in order to displace this small element is going to be the weight that is equal to we say the equal to the weight. So weight is equal to m by L g dx, which is responsible for the reaction force, multiplied by mu. Now this becomes the frictional force, and we are considering a small displacement x. So if we consider this particular thing, then the total work done can be calculated by integrating this entire thing from the length equal to 2L by 3 to the time when the total length slips off, that is 0. So we get the expression as mu mg upon L x dx. So if we solve this out, we attain the work done by friction is coming out to be equal to 2 mu mg L by 9. So this is going to be the answer for this particular problem. So we are considering that the chain is sliding bit by bit, and we have considered it in this sense that at a distance x from here, we have selected a portion of the chain which is having length dx, and as it is sliding down by this distance x, the work done by friction is calculated, and then we have integrated from this portion to this length, that is from 2L by 3 to the 0 section, because this part is going to travel a distance of 2L by 3 and this is going to travel 0 distance. So that is why we have integrated it from 2L by 3 to 0 to calculate the value equal to 2 mu mg L by 9.